Welcome everybody. Didn't even have to ask me right now. So I guess the lights was the cue, and I got around the first switch. Welcome everybody. I'm glad to see your turn on here. You're in the right place if you're looking for EBA's All-Scholar Day presentation. So I want to begin. First off, I'm Derek Craig. I'm the president of Energy Business Alliance. This is Alex Hoffmeyer. He's our current vice president. And I want to begin by asking a simple question: what is Energy Business Alliance? So in its most simplest form, Energy Business Alliance is basically just a platform for us students to go beyond the classroom, take our learning outside of the classroom, and go beyond the expectations. And we do this in a lot of different ways, and one of the ways that we do it is through numerous field trips throughout the year, and indeed we've had quite a few this year. We've been on 2 frac sites, one with Install Energy and one with Northeast Natural Energy. We've also been to an Ergon refinery in Newell, West Virginia, and most recently a Mark West cryogenic natural gas processing plant. So our members are not only getting more from our upstream operations, but also midstream and downstream operations as well. Again, just opportunities you don't get in the classroom. And we've also visited conventional production through our own Trail Tech initiative. So, Alex.
Thanks, Derek. So going off what he said, the way we've been able to go about this is through a simulated, down here, so I'm not blocking anything, through a simulated legacy company, Putnam Oil and Gas, as we have some of the polos some of the members have in the crowd. So the way it worked was, it's a conventional operator with 262 Clinton wells, and 262 vertical Clinton wells, and because it's student ran, we wanted to broaden our asset base by looking into unconventional horizontal Utica wells that we have the deep mineral rights for. The way we went about that transition process was breaking into five different stages, or 5 project meetings, like you see right here. So first we started with how we were going to raise capital for the project, going into the prospects that we had, where we wanted to drill. After that, we went into, okay, how we want to design our well pad and our respective wells. After that, we went into, okay, we need to go through the leasing and permitting process. And then finally, running some economics on the construction costs and seeing what it really was going to cost to build this well going forward. For each of the meetings, we had 1 to 2 student leads. They were members in the organization, and what they would do is they would research topics outside. They would bring it into the meetings, they would present to the membership group, and then they would work with the members to come up with what was the best way to move forward on their specific projects. All of them were really critical to making sure these projects got done, to making sure that our members understood what the topics were, because especially for sophomores who did a lot of the project leads, sophomores and some seniors, sometimes you don't get that real connection, but when those guys do it, there's a really good chance that they're going to be able to help people because they know from that perspective what they need to hear. All right, and then from there we had industry professionals that were able to come in through different companies, and they were able to work with the team leads in the meetings and show their knowledge and their experience in the field, especially around here, and really make the project more lifelike and more realistic. To back that up, they would come to the meetings and they would help out answer questions, like I said, show their experience, and really just give it the real feel that, as the point of the club is to make you ready to work on day 1, those industry professionals can help answer a lot of the questions that we have.
All right, thank you. So hopefully one of the things you're going to see in our presentation today is that our members are very driven, very passionate. They have a hunger to learn more about our industry, and so we collectively try to make sure that we're all ready for the job day 1. So that's our motto here at Energy Business Alliance. And one of the things you can see is that we got a Most Engaged Membership Award from Marietta College, so that speaks again to the volume of our members. So going forward, a quick agenda. So we're going to have a quick message from John Henson and Aaron Dillon, our founders, and then we're going to go through each project meeting. We're going to have the leads speak about what they did in each meeting, and then have some question and answer at the end and some closing remarks. So without any further ado, John and Aaron.
Thank you, Derek. So we'd like to go over a few things about the beginnings of EBA and kind of things that we hope would happen going forward. So in 2015, Aaron and I had a vision for more engaged student learning here while in school, to supplement the internship process, to supplement our education here at Marietta College. And this is something that we knew could be an excellent resource for the students at Marietta College. And it's also something that we didn't want to go away after we left, because we knew the best long-term interaction with the students would be if it were to continue. So for that reason, we were thrilled when we found Derek and Alex, and they came and they were super engaged with Energy Business Alliance, always took initiative and really showed promise. So we ended up choosing them to be the president, vice president, and lead Energy Business Alliance into the future. We can't thank them enough for the late nights, the tireless efforts, because we know what goes into it. And they've done a better job than we could have hoped. And you can see on the walls all of the work, and you'll see in the presentation the efforts that they've put in. So we have a couple of plaques commemorating Alex and Derek. So the plaque says, Energy Business Alliance in appreciation of Alex Hoffmeyer, and then there's another one for Derek Krieg for his tireless efforts to advance the students and mission of the organization.
This next award is one that will be housed within the Brown Petroleum Department with the thanks out of the Brown Petroleum Department. Basically what this was is John and I had one of our late night conversations, and we were talking about what it means to be an executive within Energy Business Alliance. And really basically an executive in any organization, when you're the president of an organization, it's a lot like running a marathon. You spend a lot of time, a lot of long hours, basically being the one that worries about everything. And when you're working with them, one of the things, if you work as an aide for an exec, one of the things you have to recognize is you're basically running a sprint, trying to get them what they need so that they can keep moving forward. And so when we were talking about this, we came up with, well, gee, that's a lot like relays and a baton. And so as a symbolic gesture of that, we got a baton made. And so what it says, it's basically the Energy Business Alliance, yeah, it's cool. So it's basically the Energy Business Alliance presidential baton. And basically what this now represents is how after each iteration of the presidents go forward, you'll get your name on the plaque and have your name within the Brown Petroleum. Derek, thank you for your work.
Thanks for starting. Thank you for your words, and without further ado, we'll turn it over to Jay to begin our project meetings.
Thank you, Derek, for the introduction, and congratulations, guys, on your awards. So I'm going to talk about today EBA's expansion into initiating new production. So when I was asked to join the executive team, I sat down and decided, okay, let's see what the company is actually at financially. So as Alex already said, we had 262 vertical flint and sandstone wells in the state of Ohio. So what I did first was looked at our production for last year. So our production for last year is we had 5,830 barrels made and 540,000 MCF. So looking at our table here, our net profit here is $1.6 million after expenses and taxes. But we have a couple issues though. So our issue is we want to expand into the Utica Shale part of the industry, but we don't have enough funding to do that. And the other issue we also have is our plugging liability is more than our income. So that was kind of the goal of the first meeting. How can we raise capital so that we can establish this venture? So the first thing we looked at was our leasehold evaluation. So we sat down and said, okay, what assumptions do we want to make? So for our assumptions, the executives decided to do 40-acre spacing for every well. Now, realistically, that's not the most ideal situation. Here's a couple of examples. I worked for a conventional operator last year, and there was a well they plugged a few years ago, and it was one well on this whole entire lease, and this lease was actually 400 acres. So that's just an example where it may not actually be exactly 40 acres. It depends on kind of your agreements and how the lease is structured. Another example is this plot map down here. This is actually a well that's about 3,800 feet, and it's actually only spaced on 20 acres. So you can have a large sum of what your acres can potentially be. So your true process is, as landmen, you typically have your landmen or office staff do this. They usually run title, they go to the courthouse, they actually sit down and look at these agreements and investigate them. Us being petroleum engineers and having between 16 and 19 credit hours per semester, it it's quite time consuming to do that, so we went ahead for the sake of time and did 40 acre spacing. So once we did that, we went into the farm out option. So I suggested for us to farm out some of our acreage. So what is a farm out? So a farm out is defined as selling a portion of a lease for particular formations to another company for a set amount of cash. For example, let's say John Smith has 1,000 acres in Guernsey County currently, and he has conventional wells on that property. So maybe Antero Resources comes to John Smith and says, hey, I want to farm into your Utica acreage. And John Smith's like, okay, I'll sell you this acreage in the Utica shale for $5,000 an acre. Okay, $5 million, sounds good. So we sit down and we decide, okay, let's craft a farm out agreement for this. So you'll craft out an agreement including that, and then you'll also include an override. So John Smith will say, okay, I want an override in the non-royalty interest between the landowner's portion and then obviously the rest of the non-royalty interest. So in an 18% example, it would be the difference between the 12.5% the landowner has and then that total 18%, so 5.5% for free, and you don't have to do anything with that particular well, which is pretty nice. The other option you can do is you can do JV or right to participate also in your agreement. So basically, if John Smith says, I really like this well, I feel like it could make me some money, he can craft a clause in there that says JV or right to participate up to a certain percentage. So you can say, okay, I want to invest 25% in this well, and I want 25%. However, it's important to keep in mind that you also be responsible for expenses and other things within the well, but you own 25%. So this is what a typical farm out agreement looks like. That document's about 20 pages. I'm not going to go through that today. So once we got that farm out option established, we sat down and looked at our prospects. So we broke it down into 3 prospects here. So we have our Guernsey acreage here, and we have our Harrison County acreage here. So looking at the Guernsey acreage here, it's the most bulk acreage and it's the most valuable right now because it's more of a popular place in the play. This is close to like the Purple Haze, so people are paying more dollars per acre in that area. With these 2 areas up here in the top, they're smaller groups, but you have the possibility maybe of expansion. So your different factors you can take in is capital, your expansion, and then IRR, which Ryan's going to talk about more in meeting 2, what that is. So here's the prospect that I proposed to EBA to take on. So I looked at the West Shore prospect specifically. There's a couple of reasons for that. On that map on the previous slide, we had our acreage up here. This gives us, because of those holes in the acreage, we actually can go out and expand our acreage because there's no wells there and those leases are most certainly probably free at the moment. So we have that opportunity. The second option is, besides the West Shore prospect, beside it, about half a mile away, it's actually water sources. So when we go in to drill and we do our completions, we're going to have potential areas where we can withdraw water to use for our processes, which makes the project more economical. The third thing is, because it's not as popular in the play right now, it's going to be more economical to do a lease cost here. So it's going to be a lot cheaper per acre. So now I'm going to give you a little bit of geology information evaluation of where we're actually drilling this well, so you can have an idea. So where we're going is, our target zone is the play is the Point Pleasant Formation. It's kind of the sweet spot of the Utica Shale. It's a transition zone. It's 60% limestone and 40% shale. It's interbedded between each other. And kind of how this formation was laid down is the Point Pleasant was laid down on a reef kind of like this, and the tectonic orogeny came in out of eastern Canada into the eastern United States, and it came in and had a mountain building that occurred. So what happened was this Utica Shale actually transgressed and regressed over top of the Point Pleasant, eventually burying that rock. So the Point Pleasant actually has the greatest zone for TOC that's been shown on previous studies of the formation by multiple universities. If you look at their logs and their core data, the Point Pleasant is actually the highest in total organic content. Looking at some averages here for the basin, our porosities range from 8 to 12%. Our water saturation is from 5 to 20% with an average of 12.5 in our particular area. Our bulk density is from 2.5 to 2.5 grams per cc, which is good in the transition zone. It's getting closer to those matrix densities of sandstone and limestone. But up here I have a cross-section of our particular area we're looking at right here, and this log here in the middle is the eddy pad. It's relatively close to where the West Shore prospect is. So there's a couple things to point out on this log particularly. So if you look at the resistivity here in the Point Pleasant Formation, it's actually increasing. So there's more electrical resistance in the rock, which means there's more hydrocarbon potential because the hydrocarbons is more resistive to conducting electricity. So that's what's going on with our resistivity there. Then if you look at our gamma ray here, oops, sorry about that. But if you look at our gamma ray here, it's going from more of a shale baseline of about 100 API units to about 50 API units, indicating a transition zone between the Utica Shale and Point Pleasant. So it's more towards that limestone base. Down here at the bottom, you can see a couple tables here. This is the top 12 counties. This is our average initial production, courtesy of UGA. Harrison is currently the most average initial production currently in this point in time. And in this table down here, for Q4 production, Harrison County actually had the highest condensate production and MCF for gas, natural gas production. So essentially this could be the next big piece of the play. Harrison's kind of been forgotten about for a period of time, so the play may increase and it may become more busy. So new economic standing. So we decided to take some of our outlier wells and sell those off. So we took about 87 of those and sold them because it would have been harder for us to operate those, especially now that we're going into unconventional. So we took our expenses from our gross and we figured out what our net profit was, and then we did a 12% decline for our next 3-year forecast. So we did that and we were able to come up with a package value of $811,000. So we did that, and then our production for last year, we had 1,159 barrels for this particular package and 119,000 MCF. That's just to give a little bit of perspective of how much of that production we may lose, but we are still getting the money for it essentially. Then you're going to have your transfer of ownership form. We'll show you that here in a second. And then our farm out calculation here. We basically base these prices based off the activity in the play and also the group's industry personnel that were courteous enough to give us some prices. So how much money do we actually have in the bank? That's the most important question. So last year we did 1.6 million in the bank. We had 9.1 million in farm out income, 811,000 in the well package. So total in the bank right now is 11.6 million, which hopefully should be enough for our Utica Shale well. But we're going to find out later in the presentation if that's the case. Here's our transfer of ownership form. And now I'm going to pass it off to Ryan to talk about NPV and also what location we picked.
Thank you, Jay, and thank you, Aaron. All right, I'm Ryan. I'm the treasurer of EBA, and I'm also the meeting lead for meeting number 2, where we were selecting for the drill. I was accompanied by Hostel Yadi, and he is a reservoir engineer who worked with Council Energy. So we're going to talk about how we wanted to look at our acreage. We wanted to compare the thermal maturity between the areas in which we were looking at, West Shore and Westchester. We wanted to check all of the sorts of values of different zones. We wanted to calculate NPV and IRR so that we would know if what we're doing is actually economical and if it's a good business decision. And beforehand, we made sure to research the production data of local horizontal wells in order to have some idea of what our well would be capable of doing. So as Jay was talking about before, our options that we had was between choosing, should we develop West Shore or should we develop in Westchester? We decided on West Shore for several reasons. In turn, it's not a huge difference in that the areas are close enough to each other that there isn't going to be a huge difference in productivity. And the nearby highway and water source are really good, useful for transportation, useful for secondary production. And the infrastructure. Since Westchester is pretty populated, it also has a strong infrastructure, but the leases are also going to be cheaper. So that would be better to develop in West Shore because we wouldn't have to pay as much. And here's the image of where West Shore is what we're looking at. The water source is pretty close. It's not too far away at all. So if we wanted to use it for fracturing, like a frac job, it would be a good source of water as long as we can permit it. And we also have the major highway down here. So there are several values we wanted to make sure we understood, make sure we got a good grasp of in order to go through with our project. We wanted to know net present value, which is basically our profits, the revenue minus our costs. And we also have internal rate of return. That is the discount rate at which net present value is equal to 0. So that means if our IRR is a high enough value, we're going to want to go forward with the project because that means that the cost of doing business is definitely worth going through them. And payout is also useful. It's a useful value to have, so we know like when is this project going to pay out, when are we going to make back on what we invested. Here are the values we used to calculate NPV, IRR, payout. We have working interest. We own all the well is with us. It's not a joint venture, so it's 100%. Net revenue interest, we're paying 15% royalties. We're expecting around 50% royalties to pay out. So 85% of our revenue is going straight to us. And shrinkage accounts for the fuel usage we have. ETU is how well the gas burns. You have various taxes and operating expenses. Variable expenses depend on how much we produce. If we produce a lot, we'll have to pay more. And fixed operating expenses are expenses that don't change no matter how much you produce. And we have oil production, decline rate, oil price, gas production, decline rate, oil price. Pretty conservative numbers, I think, using $41 a barrel, depends on the day, I guess. We account for a discount rate of 10%, and we account for escalation of inflation around 3%. Now, we did a demonstration of this in meeting 2, where I went through how we get all these sorts of values from the well data that we had from local wells. And our result was an NPV of $9.4 million over the course of 10 years. Profit investment ratio of 1.17. It payouts in about 34 months. And IRR is estimated to be around 43.7%. And that's considered a pretty good value. That means we should definitely go forward with our project. And now I'd like to turn this over to John Hinson, and he will be up here talking about our well and our well pad design.
Thank you, Ryan. Well, now that we know that our well is economical based on our estimates, and we know where we're going to be developing our asset, now it's time to work on a little bit of the design of our project and what our well profile and our land impact is going to look like. So over this meeting on February 28th, we went over designing the well pad access route, casing program, lateral link, build section, and tools used for the process. And we're just going to do a quick overview like we did in the meeting. So there's an example of a well pad. You can see the drilling rig is still on there. And here's an example of a well pad design, which is what we are attempting to do. Some considerations for pad construction, environmental. You have to be wary of streams and buildings. You can't build too close. You have to be wary of noise pollution. So if you're in a populated area, you're going to have to build walls. So you want to avoid that. And then the ground, you must protect the ground with impermeable layers and cement mixed in with the dirt to make sure that we're not polluting our environment, and we'll be stewards of the land we're working on. This is some of the considerations that go into how large our well pad has to be. Our well pad is 3 acres because, as you can see, we have plenty of important equipment that needs to go on and off our well pad over the course of development. So I won't go through all of it, but you can see it's large, heavy machinery and equipment, and this is the stuff that will stay there during production. The wellheads, GPUs, the production tanks, trailer, and you got to get rigs on and off. It's got to be easy access. More equipment that has to stay on your pad, and as you can see, it's completely filled. So a 3 acre pad is definitely necessary. Massive storage tank for water, 20 pump trucks, really large land requirement. So here is our pad design that was done by Swiss Valley Associates. A couple of the gentlemen that worked on this project are sitting in the back, so we would like to thank them for their work on doing our well pad design. You can see that our 7 wells are centered, our tentative wells are centered in the well pad there. Effectively, you can see the land cut off there, so thank you, Swiss Valley, for your work on that. It's been a phenomenal help to have the visuals, something we could not do. And another thing Swiss Valley did, and it's not the last thing they did, is they designed our lease road. So we have to connect a transportation means from the existing infrastructure to our well pad. That all the equipment that you saw previously has to be transported to and from the pad, so careful consideration with the lease road needs to be taken. So thank you again, Swiss Valley. All right, so now that we know about our pad and the kind of logistical side of things that we'll need to consider for our operation, we can start to get into the well plan a little bit, and I'll start with the directional plan. And basically what we're doing is we're determining the well path from the surface to geologic targets. So the directional plan is influenced by some of these considerations, and this is not all that it's influenced by. The geological targets, the surface location, where is your surface in relation to your target rock? Do you need to kick out? Casing wear considerations, how much does your casing need to bend in order to get to the direction you're trying to get, so you can't have too much angle. Bottom hole assembly, what are your tools, capabilities? So we're going to have, later on we'll talk about mud motors versus vertical steel. What are your tools capable? What kind of bend are they capable of getting for you? And then interference from other wells. We can't be colliding with any other well bores, or later on in the fall having our completion job we get to other well bores. So we need to have 1,000 acre spacing, 1,000 well spacing, 1,000 foot well spacing, excuse me. So here are the things that go into determining the kind of the language of the directional plan. You'll have parameters such as measured depth, inclination, azimuth. Measured depth is the travel distance from your surface location, from your rig floor to the bottom of the hole. And so it's not a straight line in our case. So it's going to be longer than what we call the true value depth, which is just literally how deep it is from the surface. And then inclination is the change in angle from vertical, and azimuth is the cardinal direction. So here are some of our points, our targets that we thought would fit well. We were able to submit to Cathedral, which I'll show you in a moment. Our target is the Utica Point Pleasant, which the prolific zone, as Jay was mentioning earlier, with the true value depth in this area of 7,800 feet. So that's literally how deep our well bore is going to be, and a lateral length. So how long the well bore would be once we get into the target zone of 8,700 foot, with a combined true measured depth, including the curved vertical section and lateral, of around 17,000 foot. Something else to consider is when we're doing our directional plan, our tools and casings should not exceed 10-degree dogleg angle. So what that means is every 100 foot, we should not have more than 10 degrees of angle change. And then our KOP, that's our kickoff point. That's when we change from vertical to a what they call a directional well, is at 1,500 foot. So that's when we start our build out, which is right here. That's the KOP. And then that will build all the way to the final curve kickoff point and land at 7,800 foot. So this is the directional plan that Cathedral was able to make for us. Thank you again, Cathedral. Thank you, Nick, for organizing this. Cathedral is a company that's been working in industry for a while, and it was awesome to have their input on our project. So this is the profile of what our well will look like, and then the bird's eye view. And then this is another example of the same bird's eye view that Swiss Valley Associates also prepared for us. So you can see pretty much uncanny the similarity. So thank you again, Swiss Valley. Okay, so now that we know what our directional plan is, we need to move into our casing and cementing. How are we going to isolate our water aquifers, ensure the well has integrity, it's going to hold up under stresses. Our casing is going to prevent the fracturing of weaker formations, keep us from losing mud later on, and prevent kicks from overpressuring zones. It's required for regulations and environmental considerations. It covers up deep zones, provides the conduit, it goes on and on. So casing is very important. And I won't go into all the details, but here is the vertical profile of our casing and cementing program, and it is straightened out. Normally this would be curved out to the side, but it is straightened out just for us to see the casing and cementing program. So first we'll have a conductor casing of 20 inches OD, and that'll go to 200 foot surface casing of 13.375 inches, and that'll go to 1,400 foot intermediate casing of 6,700 foot to cover the Queenston, and then production casing all the way to total measured depth. So Here's an example of what could be our rig based on many operators in Utica. There are different brands of rigs that are used, but Helmer Painter is one of the most prolific drilling contractors in the United States, so we chose an H&P 500 series with 1,500 horsepower pump system and drawworks, and the SCR electric distribution system. Triple stand top drive. Top drive means that the weight is above the drill string. Pushing it down lets us get out horizontally rather than the drill collars supplying the weight. And then we'll use air and mud systems. Air for the vertical section because in the Appalachian Basin we can get away with that. We're not going to see too many kicks, so we can afford to drill on air and get some faster rates. And on the same note with the air drilling, we will be using conventional directional motors. There'll be a rotor inside of a tube that will spin the bit so that we can slide in one direction. And then once we land our casing into the Queenston, we can then bring in our mud weight, our drilling mud, and move into rotary steerable for more control. And rotary steerable is a prolific invention that's come around in the past 10 years or so. That's a good thing to know about. So I would like to, after we know about all of our parameters of our well design, I'd like to invite Derek Creed back to the stage so that we can name our well pad. Thank you.
Thank you, John. So initially when we wanted to decide on the name, we went about it very democratically. And we had an idea in mind, and then the tragic news broke about our freshman member, Energy Business Alliance member, Joel Wannenberg, who passed away early morning on Thursday, March the 9th of this year. So due to natural causes. So in an effort to further his legacy, we decided to name our pad the Wannenberg Pad after Joel. And the design can be seen here. We decided to do 7 wells, as you've already seen on some of the planning. And we decided the first well we would drill would be the Wannenberg 38H, which would be named after his, in honor of his Marietta College football jersey. And if you're interested in learning more about how we're trying to further his legacy, you can visit this link at the bottom of our webpage, energybusinessalliance.org. So without further ado, I'll hand it back over to Jay, and he's going to walk us through a leasing.
Thank you, Derek, for having me come back up here. Hopefully I didn't put you guys to sleep too much the first time, but now we're going to talk about permitting, so good luck not falling asleep. So permitting, why is it important? So what is permitting first? Permitting is permission and authority to conduct a new oil and gas activity or well. So there's multiple types of permits. There's your drilling permit, there's your completion permit, your plug back permits, your injection, and your plug and abandonment. Currently we're focusing on drilling, so that's our current focus. So there's 2 factors here to think about. There's your environmental awareness piece. So when it comes down to it, you want to think about when you're developing this project, you want to do the best you can to keep our planet as well as it should be. So you want to take care of the planet and the environment around you. You want to make sure you do your job correctly. So that's one piece of the permitting to keep in check. The other piece of environmental awareness is the good neighbor policy. So staying in constant communication with people you're working with. Let your neighbors know what's going on. They know you're drilling, so they understand what processes are coming through, so they're not confused. It's kind of keeping everybody on the same page. And when you do that, it's a good working relationship, and you can get your job done more effectively. The other reason here is to give investors and operators a guide to follow when they're establishing new production. So when you're coming in and drilling, it gives you an idea of what you need to do, what you should do, what you shouldn't do, so you kind of have an idea of what you need to do. So you have that. Then you're forcing your groups to prepare ahead of time. So obviously you want to prepare and know what you're doing when you come in so that you're not trying to figure out as you go along. It also gives you the ability to adjust as you hit maybe a kick or some snag while you're drilling. The most important reason for permitting, at least in the state of Ohio, is that application for a permit through the Department of Natural Resources. The idea is you want the government and state government and you to be on the same page so they know what you're doing your process correctly, and so that you be able to work efficiently. Horizontal permits. This is other permits you will send with your application for permit. So you typically send a RUMA, that's your roadway use and management agreement. The idea behind a RUMA is to be able to sit down and actually craft an agreement where you can conduct travel on certain roads when you come in. So with the RUMA, It provides infrastructure for us to maintain those roads because there's an unusual amount of traffic on those roads. So it helps that because these counties aren't going to be able to financially support that because it's usually not in the budget and it's not usual how this kind of traffic. Also, another thing is a water test. So the purpose of the water test is you're analyzing drinking water aquifers around your well. That's run before drilling and after completions by chemical labs. In our case, we don't have any aquifers within a certain distance of our pads, so we don't have to go through that process. But when you do this, the idea is to be able to make sure there's no contaminants in your water before drilling, so you're not liable for it, and after drilling, so that you can fix the problem or look at your production, because there could be something in your casing as well. Your restoration plan, the idea of a restoration plan, it kind of details what you're going to change with your landowner's property. So the idea I like to say, it's like the old motto, happy wife, happy life, same thing here, happy landowner, happy operator. So as long as you're on the same page as your landowner, you treat that land as a guest, you come on that property as a guest, you want to treat it as if you own that land, as if it's your own, so you want to take care of that for them. Then you have your plat maps that determines the proper footing of your well, which we kind of already went through that in the drilling, or plots of land. The other thing you're also going to attach is a drill survey. It's not essentially a permit, but it gives the state an idea of where you're going on your drilling. So these are the permits that we filled out as a group when we taught some of the younger students how to do. This is your application for a permit. You'll send through a DNR. This is your affidavit here. And then most importantly, here's our casing and cementing program. So we kind of talked about the dimensions, but we didn't talk about why we're running at the depths we are. So we're running the conductor, obviously, 200 feet to protect that surface water aquifer. The reason we're running the surface through the Berea is one, for that reason, but also to prevent hydrocarbon interference from the Berea sandstone formation. Then our intermediate stream, like John says, running through the bottom of the Queenston. The idea is for 3 reasons. So one, there's a possibility of H2S in the Salina group, so we don't want H2S possibly invading our wellbore and our cement. So we're going to do that there. And then secondly, is to prevent hydrocarbon interference from the Clinton sandstone and the Devonian shales as well. And then third, the most important, in the bottom of the big line group above the Packer shale, there's actually a big section of salt water that you'll hit. So this intermediate stream helps prevent that salt water from reacting with your cement and your production stream. So that's what you'll do there. Then your production stream is obviously going to be run through TE. This is what our restoration plan looks like, pretty self-explanatory. So here's our drill survey. This is what you're going to attach with your permits so they kind of see where you're going. John already kind of covered this. So now I'm going to give it off to Nick and Dave, and they're going to talk about AFE and our economics, whether we can drill this or not.
All right, thanks, Jay. My name is Nick Charisma. I'm one of the 2 project leads for realizing the cost. Our industry lead was Catlin Bull from PVC Energy, and this is a 2-part project. The first half of the goals was to develop an AFE and determine the feasibility for drilling the Wannenberg 38H. So here's our initial AFE. Oh, AFE stands for Authority for Expenditure. So yeah, here's our initial AFE. We got a line-by-line breakdown. Here's intangible costs and tangible costs. Intangible costs, those are costs associated with things that will not be with the life of the well, while tangible costs, they are with the life of the well throughout its lifetime. For example, like casing in the wellhead. So we developed these, or we gathered these through data mining and calling individual companies and finding out what the going rate for these lines are. So as you can see, we have a cost of 1.7 million, and it's rather low. But what we did was we sent out this form to 3 different companies, 4 different industry folk, and we gathered their data and compiled it all and took the averages of them, and then we developed the final AFE. So same layout, got intangibles, tangibles. The new drilling cost is $4.7 million. So some notable calculations and assumptions we made. Right here, conductor casing, surface casing, intermediate casing. we took the casing plan that John made and we multiplied the heights by cost per foot. And then we got these three respective values for that. Location, we assumed 1.5 million. We had to, based on John's well pad plan, we had to assume a very high value for this because the access road is about one mile long. So that's going to be very costly. So we had to assume a high number, so 1.5. Also, up there at the top, rig crew safety bonus. As you can see, there's no number for it. That's because in this industry right now, it's not feasible. So we can't do that. It's not economical. And then finally, contingency costs. Contingencies, those are unexpected things that happen. As you can see, it's $600,000, and the factors going into that are an inexperience factor. So we're brand new to drilling in the unconventional reservoirs. So we have an inexperience factor because we'll have some screw ups at some point. So also the contingency cost is including the premium for it's our only well, it's our only asset. So that means if we screw it up, we're in trouble. So we have to pay a little bit extra for that. So one thing to note is that we moved the location from intangibles down to tangibles. We did this because we didn't realize at first in our first estimate, our first draft of the AOP, that we just made a mistake and we got the definitions mixed up, I guess. So yeah, you take intangibles plus tangibles, you get the total drilling cost at $4.7 million. All right, I'll pass it on to Dave McCabe now. Thank you.
All right, thank you, Nick. All right, so the goals for the second half of the meeting. Basically, the first goal is how accurately can we predict our reserves. Our reserves are the only cash we're getting back from the well, so we need to predict those and look at the feasibility of drilling once more. And for this, we used a Monte Carlo simulator, which we'll talk about in a little bit. Next, we want to know what our profit margin is. Again, that factors in to decide whether we're going to drill or not. In this, we just used estimated reserves multiplied by our recovery factor, multiplied by the sale price per BOE, and then we subtracted off the cost of the well. And so basically, that's our profit margin. And so then finally, we asked the question, do we proceed with drilling? All right, so we're back to the AFE, as Nick mentioned. The drilling total is 4.7 million. Technically, the drilling total is not 4.7. It's 3.2. The location cost we get to keep as equity because we can drill more wells on there for no extra cost. So this is important in the next slide. We didn't draft an AFE for the completions aspect yet. It'll be next semester. That's what we're working on next semester. But we need a ballpark estimate for the total cost of the well. And so what we did was we looked towards industry standards as far as expenditure breakdowns go. So in an unconventional well, 40% of the cost is in drilling. About 60% of the cost is in stimulation and completion, basically. So we took the 3.2 million, which is the deducted cost of our drilling, minus the location fee. We set that equal to 40%. We extrapolated out to 100%, which is 8 million, and then we added back in the cost of our location. So we're spending about 9.5 million from basically location to production. Production is when we start having a revenue, basically. And so this is important going forward. Operators and companies are looking to make 3 times their initial investment over the life of the well. And so this is what we're going to look at with a Monte Carlo simulator. So what is a Monte Carlo simulator? It's just a technique used to analyze risks and uncertainties in financial project management. And we're applying it to drilling, but there's plenty of uses outside of the oil and gas industry. And like I said, we use it to gain a better understanding of reserves and potential profit margins. And industry operators use many more complex systems or programs, but we just focused on the basics. We thought it would be good for everyone to understand what a simulator is, how it works, and its uses in the oil and gas industry. So here's our Monte Carlo simulator. I'm going to briefly explain to you, how it works. We have our gas in place equation. The coefficient on that is actually wrong, but it's the gas in place equation that everyone learns here in freshman year petrophysics. So we just picked a simple equation. There are more complex equations that you can do, but it illustrates it well. So we have our variables up here for we have our values for our variables, and gas in place is a function of area, height, porosity, water saturation, and formation volume factor. And so we got these values by just data mining, looking up investor portfolios and investor presentations. And so what we do is we also created standard deviations. Standard deviations just tell you how much those values can fluctuate in a RAND function, a normal RAND function. So then we randomized those values and we ran 1,000 iterations of it. So again, we just took those values with respect to our standard deviations. High standard deviation means that they vary wildly, and low means that they don't at all. We then group those into bins, so those are all reserves in BOE. We can then graph a cumulative distribution plot. Basically what this tells you is that with 40% chance of getting about 850,000 barrel BOE from our reservoir, and the recovery factors factored into this. So our main conclusions, 90% is what we call probable. So it's probable that we'll find 740,000 barrels of oil equivalent over the life of the well. And we multiplied that by the cost of condensate currently. And we found that it'll come out to about $31.8 million. So this is not factoring in fluctuations in condensate prices, nor is it valuing our dry gas production at all either. So those are things that you could factor in. So in the meeting, we split up into teams. We looked at variables that needed altered or changed, and we talked with Nick, and I discussed with Catlin during that time as well. And we found out that we were an order of magnitude off in 2 different variables. So it was due to a mix-up in conventional versus unconventional data, and so. Honest mistake, I guess, but it worked out well because one, we were in order of magnitude higher, one, we were order of magnitude lower, and so the values came out to be about the same. And so those values that you just saw in the previous slide are our final values. So we conferred as a large group, reran the economics with the new variables, and we decided as a group that the well was economic, and we were going to drill it. So future considerations. We didn't have the intellectual capital to run decline curve analysis at this point. So we haven't gotten that in our classes. We're still a pretty young group. So we used a Monte Carlo simulator, but we know going forward that's one of the things that we're going to have to do is decline curve analysis gives you production versus time, and it shows you rate of return. And those are both things that you need. How fast are we going to get our money back, and those sorts of things. So those are in future considerations. I'm now going to hand it off to Derek to talk about our portfolio.
Thank you, Dave. Yeah, so this has been floating around the room, so we have to really condense everything that we did this semester into this 1 hour long presentation. But it's been floating around the room. You can get a sample of it here, and you can find it on our website as well. So this is going to lay out much more detail everything we went through and all the considerations that were made this semester. So you can check that out. And so going forward, our future plan, some of it has already been hit on. So in this fall, we want to look at our frac designs. We're going to start trying to get that well into production. And also we're going to be hopefully partnering with the other campus petro orgs and doing a conference or an exhibition this fall. And in the spring, we hope to look at our flowback and production equipment and our regulations that are required in that regard, and also looking at production optimization and possibly revisiting our conventional wells. So without any further ado, I'd like to invite all of our meeting leads back to the stage, and please give them a round of applause for all the hard work and also our members as well, all the teams and everything, all the encouragement and support. So we're going to open up for a few minutes of question and answer, and by all means, fire away. Yes, Noah.
My question is specifically for Ryan. When you were doing the factors with the value that you would own 100% of the well, you had your gas per barrel was something like $43 to $44. How did you go about finding that value? I know you can look it up, and then it fluctuates every day, basically. Did you take it as a weighted sum over a period of X number of years, or just that particular day?
We chose that particular number as like a very conservative estimate because this is when we were deciding like, should we actually go forward with this or should we look somewhere else?
Okay.
So this was a very conservative estimate. I chose a pretty low value of oil. It's probably 50 right now, something like that. So choosing $41 was just a lowball estimate so we could make sure that maybe, well, we just wanted to make sure that we could go through with it.
Right.
And it turns out we could.
Okay.
We hope it doesn't go down that low.
Right.
Yeah.
Anybody else?
My question's for Dick. On you guys' AFE, when you're talking about contingencies, did you guys factor in there for P&A? I mean, there is a possibility that, you know, you guys may have a failure. I didn't see plug and abandon in there.
No, we did not consider that.
It's something to think about.
We used a 15% contingency factor. We multiplied the total cost by 15%. We got that value from industry professionals, and we asked them about inexperience factor and all that stuff I was talking about, and they all suggested 15%. So I guess it's all encompassing with it. So.
Thank you. That's something.
Yeah, I mean,
Yeah,
we
it
have to have
definitely
a
is.
separate section for that too.
Okay. Yeah. Thank you.
Well, let me ask a petrophysics question, surprisingly enough. You were showing a range of water saturations that goes down as low as 5%, which surprises me.
Yeah,
And I wonder if you have any comments on that.
Yeah, so a lot of that data we actually pulled from just records we had and from a total average. So it's just kind of a range in the basin where it would be from 5 to 20%. Typically, like in our specific area, we actually had an anonymous source give us some information. Their water saturation was more like 6 or 7% average in that particular area, but we worked off averages because we didn't receive that data until later on. I don't know if that answers your question. But it was kind of more like averages we worked off of and we just looked at our data.
It is still very low.
But it is still very low. But most of your water is going to come, your water production initially is going to come from your frac when you're going to flow back, essentially.
Well, that's your water production, but your water saturation.
In your rock, yeah. And I'm assuming that's
And
probably more
maybe it's being given as a bulk volume rather than a pore volume, in which case it would be high.
Because that was something I thought about too. It'd be nice to see that effective or non-effective water saturation averages as well.
Oh, yes.
In your initial deciding on well placement, why did you decide to drill in the wet zone at this point?
In what?
In a wet gas area versus a dry gas?
Yeah, so on that slide that I have a map of our play trends in the place, what we were looking at there was initial production like we talked about, but that particular area makes a sort of a wet gas, so when that wet gas comes to surface, it actually makes condensate out of that gas due to the temperature change. So we factored in that we could make money off the gas, obviously. It would require a little more production process to do that, but you're also going to have another revenue of condensate coming in. So essentially your condensate's worth more than your gas, so we figured that would be a more economical plan because we have a higher income off of production. Would you like to expand on that? Yeah.
So also, one of our constraints was where we had existing production and acreage, and we were trying to build on that acreage, and it just so happened to be in the wet gas zone, conveniently.
It's also cool that UGA published it as the highest IP, MCIP equivalent. So kind of some backing on that as well. And then these are the maps that in the first meeting we looked at these maps and we looked at where the clusters of our acreage lie, and most of the larger clusters that would support horizontal drilling were all around the Harrison Guernsey County area. Yeah.
So, kind of building on that, have you looked at how far you are from a pipeline? In terms of your infrastructure costs?
Yeah, that's something we're going to get to. Yeah, that's something we're going to actually do when we do our completion of production design. But when I actually looked at this acreage, I essentially kind of looked around and seen all the activity in the area. So like to the northeast a few miles, there's quite a bit of Chesapeake activity. So betting off of that, we can kind of make the assumption that there's got to be some sort of infrastructure in the area for all those group of wells. So essentially that was kind of my theory, was look at that, and then when we grow our production, we can look at how we set that up and then see if we can make some sort of improvement with Chesapeake to do that. Does that answer your question?
Yes.
Okay, so a little push for time, but I'd like to still go ahead and do this. So we have some recognitions that we made up for all of our team leads. So I'd like to dish those out here real quick for all their hard work and effort. So we got a little recognition awards made up. So Jay Chapin. Jesse Eicher, who wasn't able to attend. John Henson. Nick Prisman. We also have another meeting, Alex Shook, who I don't believe is in attendance with us today. But I'd also like to ask Mason from Swiss Valley Associates to come up and accept this recognition as well. Everybody put a ton of... It would be a word. Anyway, everybody put a ton of work into our project, and we just wanted to recognize everybody. Thank you so much for all of your help. Thank you. Look back, so ended on a high note there. Perfect timing. All right, so seriously, thanks everybody for coming out. President Rue showed up for a little bit, he's not here now, but thank him for his time and everybody who came out and some family members who support as well. So thank you guys and look forward to what we do here in the future. Thank you.